Hello, geometry students. This is Mr. Pizzotto again, and we're going to take a look at page 14 in our Chapter 3 notes packet. And today we want to talk about the triangle inequality. So in these two examples that you see on the screen, tell whether the lengths of a triangle can be 4, 7, and 10. In example 2, what are some possible ranges of a third side given 6 and 12 are the two main problems that we want you to be able to solve. So we're going to take a look at some pictures here. So if you look at this picture, I have sides of 7, 3, and 12. And the question is, can I make a triangle? So I can drag these yellow dots here, and we could probably see that that's not quite long enough. So in this particular problem, we would not be able to make a triangle. The sides of 7 and 3, they just can't make a triangle when the third side is 12. Let's take a look at sides 7, 9, and 12. So if I were to drag this side or blue side, you can make a triangle. So you can kind of see that. So in this particular example, we were able to make a triangle. The sides were 7, 9, and 12. In this problem, the sides were 7, 3, and 12, and we could not make a triangle. Okay, and here I got another example. Side is 7, 1, and 5. If I were to try to connect these, we can kind of see the blue and green side are just a little bit short. If I were to make that blue side have a length of 2, it's still kind of a little bit short. It's pretty close, but not quite there. I can't quite make a triangle. But I do seem to form a line, but I can't really make a triangle here. It's pretty hard to drag those yellow dots. So kind of what's the punchline here? In those examples, the main idea here is the following. The sum of the two smaller sides of the triangle, so the two smaller sides must always be bigger than the largest side. So when you add up the two smaller sides, it must be bigger than the largest side in order to make a triangle. So in example 1, the 4 and the 7 are the two smaller sides. So you're asking yourself, is 4 plus 7, is that bigger than 10? So I'm really going to put a question mark here. So 11 is bigger than 10, so you can make a triangle. And it must be a strict greater than. When we look at this example that I was doing here, the sides were 2, 5, and 7. So when I look at the sides of 2, 5, and 7, I'm going to put that here. 2, 5, and 7. 2 plus 5, is that bigger than 7? We get 7, is that bigger than 7? No. You cannot make a triangle. I just kind of did another example here. Let's look at the other one that we did. Here the sides are 7, 9, and 12. The two smaller sides are 9 and 7. 9 plus 7 is 16. That is bigger than 12. So you can make a triangle here. The two smaller sides, 7 plus 9 is 16. That's bigger than 12. In this example, if I try adding 7 and 3, I get 10. That's not bigger than 12. So you cannot make a triangle here. So that's called the triangle inequality. The second problem here is find the possible range, or find the range of possible lengths for the third side of the triangle if two sides are 6 and 12. I'm going to use this other computer applet. So here, down in the corner, you see the sides are 6 and 10. So the red side is 6, blue side is 10. And if I were to move this dot, you could see the triangle. So the question is, what's the longest the third side could be, that green side, and what's the shortest? So the longest it could be, if I keep going, eventually I'm going to get a straight line, and how long is that going to be then? 16. The shortest, if I go the other way, eventually they'll lie on top of each other, and that distance is 4. So how do you get the 4 from the 6 and 10? We subtract. How do you get the 16 from the 6 and 10? We add the two numbers. So going back to our notes page, the second thing we wanted you to learn, so that was learning target number 1. Second thing we wanted you to talk about is the third side of a triangle is always trapped between the sum of the two sides and the difference of the two sides. And make sure you always subtract the larger minus the smaller. So in problem number 2, what is the third side trapped between? Well, the longest it could be is you add the 6 plus 12, so 18. The shortest would be subtract, so 12 minus 6, which is 6. So I'm going to write that right down below here so we know how we got that. We did 12 plus 6, and here we did 12 minus 6. So if I give you two lengths of a triangle, you should be able to tell me that third side is trapped between 6 and 18. So take a look at problem number 1. I'm going to leave this up on the screen. Can you make a triangle with those three sides? Try problem A, B, and C. Remember, the sum of the two smaller sides must be bigger than the third side. So go ahead and try that one. Right, so let's see how you did. So in letter A, I would ask myself, is 7 plus 10 bigger than 19? Is 17 bigger than 19? No. So you cannot make a triangle. I'm going to just write no triangle here. You cannot form a triangle. All right, let's see what you did for letter B. So 3 and 4 are the smaller sides. So is 3 plus 4 bigger than 7? Well, is 7 bigger than 7? No. So no triangle possible. And in letter D, or letter C, is 4 plus 6 bigger than 8? So 10, is that bigger than 8? It is, so a triangle is possible. So I would say yes, a triangle is possible. Now I'm going to add a letter D here because sometimes the numbers are not in order. So if I said 13, 5, and 12, don't just do like the 13 and the 5. Your work would be incorrect. You always want to do the two smaller sides. So you want to do 5 plus 12. Is that bigger than 13? So 17 is bigger than 13. So yes, a triangle is possible. So be careful. The numbers are not always in the same order. All right, and then example 2 is similar to example 4. So go ahead and pause the screen and write down the possible third sides for problem number 4. Okay. Welcome back. So the third side is trapped between 8 plus 13 and 13 minus 8. Remember, you always want to do the big number minus the small number. So 13 plus 8 is 21. Some people put x instead of third side if you prefer to do that. And 13 minus 8 is 5. So the third side is between 5 and 21. Okay. Go ahead and try examples 5 and 6. All right, so for example 5, the third side, I'm just going to call it x this time, would be 22 plus 17. And then 22 minus 17. So doing the math, we get 5 is less than x, less than 39. So the third side is trapped between 5 and 39. For example 6, again, the same idea. I'll just use x this time. So it would be 17 plus 12. And the smallest would be 17 minus 12. Doing the math, we get 5 is less than x, which is less than 29. So the third side is trapped between 5 and 29. So to just do a quick recap, the learning target today at the top of the page, was to understand the first learning target here, that the sum of the two smaller sides is always bigger than the largest side. That would be example 1 and example 4 that we did. And then the second learning target was the difference between the two sides is less than the third side, which is less than the sum of the two sides. So we always want you to be able to find what the third side is between like example 2.